Alright, today's question is single element in a sorted array. So we're given a sorted array. So right away we're thinking, okay, sorted array. What do we know about sorted arrays? Binary search only works on sorted arrays, so we'll keep that in the back of our mind. And then we continue reading the question. It says every element appears twice, except for one element that only appears once. So in this case, 2 is the only element that appears once, and 10 is the only element that appears once. And then we're given the hint, your solution should run in O of log n time. So at this point, now we're even more confident that they probably want binary search, because binary search also has a runtime of O of log n. Okay, so let's see how binary search can help us in this question. So with binary search, the idea is we probe the middle, and then from information about probing the middle, we can figure out which half definitely does not have the answer. So which half can we discard? Okay, so here we will probe the middle. This looks like it's length of 9. So 9 divided by 2 gives us 4. So we're going to probe right here, 4. So what can we tell about this that will tell us that the left side is the one with the answer 2? So let's compare this with a regular array. So array with no single element. So everything has a pair. So 1, 1, 2, 2, 3, 3, 4, 4, 8, 8. And you can see here that the partner of 3 exists on the right side in a regular array. Whereas here, when we check the right side, we find that it's 4, it's not 3. So that is a hint to tell us that something wrong must be happening on the left side. So let's see what a regular array has. So for an even indexes in a regular array, that's the start of a pair. So here, 0, this 1 starts a pair, 2 starts a pair, 3 starts a pair. So 0, 2, 4, 6, 8. Okay, what about for odd indexes? So odd indexes, we see that it completes the odd minus 1 value. So it's the same as odd minus 1. So here, 1 completes 0, 3 completes 2, and 5 completes 4. So in this case, we see that our probe, we probe at an even index, so it should be the start of a pair. So we check the right side. And what we notice is that the right side is a different value. So that means the corruption of this array must have happened somewhere on the left side. Otherwise, we would see, something normal like this going on. Okay, so what we'll do is we will shift our right window to our middle. So now we've shifted this right window right here. So we have our new array, 3, 3. Now notice we didn't discard this index as a potential solution, because we could have a case like 1, 1, 2, 2, 3, 4. So we probe here, and we want to make sure that since 3 is a possible answer, we don't accidentally, put it here, put our right window here, and we lose our answer. So we keep right with mid. Okay, so here we probe the middle again. Middle looks to be here. And again, this is an index of 2, which is even. So we check to see if the right side is the partner. And here the right side is not the partner. So that tells us, the error must be somewhere on the left side. So again, we do right equals mid, and we get 1, 1, 2. Now we probe here, and this is an index of 1. So what does odd indexes tell us? They tell us that they should complete the odd minus 1. So they should be the same as the odd minus 1. So here, odd minus 1, they're both equal to 1. So this pair is complete. That means we want to set our left somewhere onto the right side. So this will be equal to mid plus 1. So in this case, we can skip the middle because we know that it completed this pair. So the problem must be somewhere after it. So at this point, we have left is equal to right. We're bounding on the same element here. So both sides agreed that one element looks fishy. And this is the element that we'll return. So we'll return nums at left. Okay, let's try coding this out. So in binary search, we will have a left side and our right window, which will be the last index. Now, while left is less than right, we will perform our binary search. And then by the end that it exits, we have this condition that left is equal to right. They agree on the same element that is being weird. So we can return nums at left. Okay, so what goes on inside binary search? We probe the middle. So here we've probed the middle. And now we need to know if the middle is even or odd. So if middle is even or middle is odd. So if middle is even, so how do we detect that? We do mid and 1 is equal to 0. Similarly, you could do something like mid mod 2 is equal to 0. So that's the same meaning. I like this way because it's like it's a little bit manipulation trick and it's kind of cool, so I'll keep it. Okay, so we have that. So if middle is even, then that means the mid plus 1 should be the partner. This is in a regular world, so in a good world, mid plus 1 should be the partner. So let's check that. So if mid, nums at mid is equal to nums at mid plus 1. Well, actually here in our example, what do? We check to see if they're not equal, and then okay, so let's do that. So if they're not equal to mid plus 1, then we know that the corruption happened is on the left side. So we'll shift our right side down, just like what we did in the example. Now, what's the else clause here? The else clause is that we reach this case where we probed here, and 5 is also good. That means we can actually move our left side window all the way up to here, because this is a completed pair. So if everything looked good, then our left can be mid plus 2. Okay, so let's do our else clause here. So here, middle is odd. So that tells us that if middle is odd, then mid minus 1 should be the partner. So let's check that. So if nums at mid does not equal nums at mid minus 1, what does that tell us? So they are not the partner. So that means our corruption should have appeared on, let's see, what case are we talking about? So we're here, and then it seems like this is not the value that we're looking for, so it's somewhere on the left side. So here we'll have right is going to be equal to mid minus 1. Now in this case, we can safely do mid minus 1. So let's take a look at this. Let's say we have 1, 2. I don't know, maybe we can have 2, something like that. So we have 0, 1, 2. And because we know that this should be completing this partner, so if they're not equal, then the corruption happens on the left side. So the corruption cannot be 2 itself. Okay, so right equals mid minus 1. Otherwise, we have this case right here, where we did left is equal to mid plus 1. Okay, so at the end here, they should narrow down on a single element that is being weird. And since we're guaranteed that this single element must appear once, then we shouldn't run into an infinite loop. Okay, let's submit. Cool. All right, that's the end of today, and I'll see you on the next one.